Okay, this lesson is Chapter 4, Lesson 4.2, Lesson 2, Compare and Order Rational Numbers. Okay, the first thing we're going to start off with is comparing rational numbers. So, now remember, rational number, includes the natural numbers, or the counting numbers, whole numbers, integers, fractions, and decimals. Okay, so now we're comparing them, and we're going to use greater than, less than, or equal to. Okay, so let's look at number 1. 2/9 and 4/9. Now the first thing you need to look at when you're comparing fractions is if they have the same denominator. In this case they do. And that's a lot easier because all you need to do now is compare the numerators. So we have 2 and 4. So you can either ask yourself which one's smaller, which one's larger. So let's do which one is larger. Is the number 2 larger than 4, or is 4 larger than 2? 4 is larger than 2. So what that means is 4/9 is larger than 2/9. So now we have to take our symbol, and again we have greater than, less than, or equal to, and we have to put it in that circle. So when we read this, we know that 2/9 is less than 4/9. Okay, so we do exactly that. 2/9 is less than 4/9. Now remember, with the symbols, the mouth, of the alligator is always open to the larger number. Okay, and when you read it to yourself, 2/9 is less than 4/9. That makes sense. So that's the correct answer. Number 2, we have -1/8 and -3/8. First thing you do is you see if they have the same denominator. They do. So now we have to compare the answers, compare the numerators. But this one's a little different because it's negative. So you have to think about that. Think about the negative. Now, if we had these on the number line, right, which number would be closer to 0? -1/8 or -3/8? Now, if we just drew a small little number line here, right, remember we would have 0 and then we would have -1. Okay, so -1/8 would probably be over here, right? -1/8. And then -3/8 would probably be right over here. So, remember, with negative numbers, as you move to the right, the numbers are getting larger. And as you're moving to the left, the numbers are getting smaller. It's the opposite. So now we look at this and we say, okay, well, we have -1/8 and -3/8. So which number is larger? In this case, it's going to be the -1/8 because it's closer to 0. So in that circle, we're going to put -1/8 is greater than -3/8. Now let's look at number 3, 6/10 and 3/5. Now this one, again, we look at the denominators and see if they're the same. In this case, they're not. Now, something else you could do is if your fraction is not simplified, you need to simplify it. Now, 6/10 is not simplified. So let's simplify that. Both numbers can be divided by 2. 6 divided by 2 is 3. 10 divided by 2 is 5. Oh, wait a second. That's the same number as the one on the right side. So if we wrote that 3/5, they're the same. So the sign that's going to go in the circle is going to be equal to, because 3/5 is equal to 3/5, right? But now we have to rewrite it up top. So what this is saying is 6/10 is equal to 3/5. Example 4. We have 3/4 and 4/5. Now, are the denominators the same? No. They have to be the same in order to compare them. Both of them are simplified, right? So we can't do anything with that. But what we have to do is we have to find a number that is a multiple of both denominators. So first what we're going to do is we're going to list the multiples of each denominator. So the multiples of 4. 4 times 1 is 4. 4 times 2, 8. 12, 16, 20, 24, 28, and we'll stop there, dot, dot, dot. Now let's list the multiples of 5, and we're going to see if any of those multiples is the same as any of the 4's multiples. So we have 5, 10, 15, 20. Ding, ding, ding. They both have a multiple of 20. So our least common denominator, LCD, is 20. Now that's very important because what that's saying is that we want both denominators of these fractions to be 20. So in order to do that, what I do is I draw a rectangle and I split it in half. You take the two fractions and you put them inside on the left. So we have 3/4 and we have 4/5. Now these fractions need to change to have a denominator of our LCD, which is 20. So I'm going to draw a little arrow and a fraction bar. And again, we want both denominators to be 20. So I'm going to write 20 in the new denominator. So the next thing that you have to do is you have to ask yourself, what number times 4 gives you 20? 5. Whatever you do to the bottom, you have to do to the top. So 3 times 5 is 15. So that is our new equivalent fraction for 3/4. So let's move to the next one. What number times 5 gives you 20? 4. Whatever you do to the bottom, you do to the top. 4 times 4 is 16. And now we have our new equivalent fraction to 4/5. So what we're going to do is we're basically just going to replace 3/4 with 15 over 20. Okay, so now since they have the same denominator, we can compare. And the way we do that is we compare the numerators. So our numerators, we have 15 and we have 16. So we have to think of what symbol we're going to put inside the circle. So that's either going to be less than, greater than, or equal to. So let's read all three. 15 over 20 is less than 16 over 20. That could work. 15 over 20 is greater than 16 over 20. Nope. 15 over 20 is equal to 16 over 20. Nope. Okay, so what we're going to do, our answer is less than. So now when we go back to our original problem, okay, we're going to say that 3/4 is less than 4/5. Okay, so example 5. Now we have negative 9 over 16 and negative 7/10, or 7 over 10. Now, first thing we ask, do they have the same denominator? No. They need to have the same denominator in order to compare. So what we're going to do is we're going to find the multiples of 16 and 10, and we're going to see which one they have in common. So, for the multiples of 16, 16 times 1 is 16. 16 times 2 is 32. 16 times 3, 48. 16 times 4 is 64. 16 times 5 is 80. And 16 times 6 is 96. Sorry about that. And we'll stop there. Okay, now the multiples of 10. 10, 20, 30, 40, 50, 60, 70, 80. Ding, ding, ding. That is the multiple that they have in common. So, since 80 is the multiple they have in common, that is going to be our least common denominator. So what that means is that we need both of these fractions to have a denominator of 80 in order to compare them. So, I'm going to make the rectangle. going to split it in half. Going to take our fractions, negative 9 over 16 and negative 7 over 10. Put them in the rectangle. Then we're going to draw an arrow to our new fraction. Okay, now we want both of these denominators to be 80. So I'm going to put 80 in the denominators. Then we have to ask ourselves, what number times 16 gives us 80? So there's 1, 2, 3, 4, 5. So whatever you do to the bottom, you have to do to the top. So negative 9 times 5 would be negative 45. So now we have our new equivalent fraction. Now what number times 10 gives us 80? 8. Whatever you do to the bottom, you do to the top. 7 times 8 is 56. I'm sorry, negative 7 times 8 is negative 56. So now we have our new equivalent fraction to negative 7 over 10. So now we're just going to replace our original fractions with our new ones. So we have negative 45 over 80 and negative 56 over 80. Now, we come to the point where they both have the same denominator, which we wanted. So now what we have to do is we have to compare the numerators. Now our numerators is negative 45 and negative, negative 56. But we have to remember something. We're dealing with decimals here. So remember, you have to think which number is closest to 0. Negative 45 or negative 56. You can also think about it as temperature, right? Here's 0 degrees, right? So the negative 1, negative 2. Now think about it. Which number, negative 45 or negative 56, is the coldest, right? Which one is the lowest one? Negative 56, right? Because first you would hit negative 45, and then you would go down to negative 56. So negative 45 is larger than negative 56. So when we put our symbol in, so we can either put less than, greater than, or equal to. So let's read them all. Negative 45 over 80 is less than negative 56 over 80? No. Negative 45 is greater than negative 56 over 80? Yes. And negative 45 over 80 is equal to negative 56 over 80? No. So, we do that, we come over here. Now we can say that negative 9 over 16 is greater than negative 7 over 10. Okay, now we're comparing two different types of rational numbers. We have a percent and we have a fraction. So what we're going to do is we're going to convert them both to the same type of rational number. Now, you can convert them both to fractions. So since one's already a fraction, you can convert 20% to a fraction. Or you can convert them both to decimals. I recommend to convert them both to decimals because if you convert 20% to a fraction, it would be 20 over 100. Then you would have to simplify. And then you would have to find the LCD. But if you just convert them both to decimals, it goes a little faster. Now, 20% as a decimal, we can do that pretty quickly because all we have to do is we have to move the decimal point 2 spaces to the left. 1, 2. Okay, so 20% turns into 0.2. Now, the 0 doesn't have to be there. You can put it there, but I'd rather you not. Okay, so now we have to convert 5/8 to a decimal. And when you convert a fraction to a decimal, you need to divide. Top in, bottom out. 8 goes into 5 0 times. 0 times 8 is 0. 5 minus 0 is 5. There's nothing to bring down, so we need to add a decimal, bring it up, add a 0, bring it down. 8 goes into 50. How many times? Well, let's see. 8 times 5 is 40. 8 times 6 is 48. Oh, we can use that. 6 times 8 is 48. 50 minus 48 is 2. Bring down another 0. 8 goes into 20 twice. 2 times 8 is 16. 20 minus 16 is 4. Bring down another 0. 8 goes into 40. Oh, 5 times. Evenly, right? Because 8 times 5 is 40. Okay, so 5/8 turned into 0.625. So now we can compare those decimals. When we compare decimals, okay, you can look at them or you can line them up. Now, if you're not sure, if you're not 100% sure that you know which one is larger, you line them up. Now, when you do that, you have to line the decimals up. So look at that, and we put this one underneath. Okay, now if there's no numbers, you can put zeros as placeholders. Okay, let's make a line here, and here, and there. We can do one at the end too, in the front. Okay, so what we're gonna do is we're gonna start from the left side, and we're going to go place value by place value. So we're in the ones place. Now, can we compare? No, because they're both zeros. So we move on to the next. The tens place. Can we compare here? Yes, one has a 6 and one has a 2. Let's do this. Which one is smaller? 2 is smaller than 6, right? So this is the smallest one. So now when we go back, we know that 0.2 is less than 0.625. Now in our original problem, what that means is that 20% is less than 5/8. And that is your answer. Okay, next is order rational numbers. Now this is basically taking everything that we've been doing, okay, and putting it into one. So the first example says, order the set of numbers from least to greatest. So that should be underlined, least to greatest. Okay, so the set. Okay, I'm not sure if the other problem recorded my whole thing or not. I'm sorry if it didn't. We're going to do another example though, just in case. Order the set of numbers from least to greatest. Okay, so what we're going to do is we're going to take these rational numbers and we are going to order them from least to greatest. But the only way that we can do that is if we have them in all one type of rational number. So because we have decimal, we have a percent, we have a fraction, we have another percent. So what we're going to do is we're going to convert all of these to decimals. Now, 0.64 is already a decimal, so we don't need to do anything with that. So we need to convert 67% to a decimal, 3/5 to a decimal, and 69% to a decimal. So let's start with 67%. To change a percent to a decimal, all you need to do is take the decimal point and move it 2 spaces to the left. So 67% as a decimal is 0.67. So we got that one now. Now let's do 3/5. Now 3/5 is a fraction, and to write 3/5 as a decimal, we have to divide. So I'm going to do that over here. Top in, bottom out. 5 goes into 3 0 times. 0 times 5 is 0. 3 minus 0 is 3. Nothing is left, so we have to add a decimal. Bring it up. 0, bring it down. 5 goes into 30 6 times, evenly. 6 times 5 is 30. 30 minus 30 is 0. So 3/5 as a decimal is 0.6. We got that one. Now 69%, we'll put that here. To change a percent to a decimal, we move the decimal point 2 spaces to the left. So now we have 0.69. Okay, so now we have to compare. We have to compare these decimals and list them from least to greatest in their original form. So I'm just going to erase this and we're going to compare them. So we have 0.64, 67% was 0.67, 3/5 was 0.6, and 69% was 0.69. So now I'm just going to break them up so we can compare and order. Now, since there's no number over here, we're just going to put a 0 as a placeholder. So first thing that we do is we look at the ones place. Now, can we compare in this place value? No, because they're all zeros. So then we move on. The 10th place, we have a 6, 6, 6, 6. Can we compare those? No, because they're all 6s. Then we move on to the 100th place. We have a 4, 7, 0, 9. Okay, which number is the smallest? 0. So I'm going to put a little 1 right there. Okay, now the next one. We have 4, 7, and 9. Which one is the smallest? The 4. I'm going to put a 2. Okay, now we have 7 and 9. We can cross those out. 7 is the smallest, so we have 3. And then 9 is the largest. So now what we have to do is we have to list these decimals in their original form from least to greatest. So we said that 0.6 was the least. Okay, now 0.6 we got from 3/5. Okay, so I'm going to write over here. So 3/5 is the least. The next one we said was 0.64. Okay, now 0.64 in this case was already given to us and it's in a decimal form, so we can just write 0.64. Now the next one was 0.67, okay, which we got here from 67%, so we have to write 67%. And then the greatest is 0.69, which we got from 69%. So that is our greatest, and we just ordered rational numbers from least to greatest.